This is the last video that goes with the biological chemistry PowerPoint. So just to review, we went over atomic structure, chemical bonding, water properties, and this is the last part, which covers pH. So your learning objective for the pH section is to describe the property measured by pH and the difference between what we call acidic and alkaline solutions. Now, alkaline is just another word for basic. So right here, I wrote the definition for pH. It's a measure of hydrogen ion concentrations. Now remember, an ion is an atom that has a charge on it. So it's positive or negative depending on whether that atom has given up or accepted electrons. So when I say a hydrogen ion, it is a hydrogen atom that has lost its electron. So let's begin by looking at water. So I'm going to go to the whiteboard. A moment here. So the first thing I want to talk about is what I mean when I say the concentration of hydrogen ions. So now most of you have probably heard that pure water is a neutral pH. So let's look at what that means. So remember that the water molecule is 2 hydrogens and an oxygen, so H2O. Now in pure water, some of these water molecules break apart. And when they do this, they form a hydrogen ion and what we call a hydroxide ion. So this is what it will look like in a chemical reaction. Now that arrow means a chemical reaction is occurring. So after water breaks up, you are left with a hydrogen ion, H+, plus a hydroxide ion. Now the hydroxide ion has a negative charge. It took that electron from the hydrogen. Now what's important here is that for each water molecule that breaks up, you have 1 hydrogen and 1 hydroxide ion. So if you have, say, 7 water molecules, 10 water molecules, it doesn't matter. The concentration of hydrogen ions will equal the concentration of hydroxide ions. That's what neutral means, is that you have the same concentration of both of these types of ions. So let's take a look at the actual value when we say pH 7. This is referring to the concentration of hydrogen ions in the solution. Okay, so that's what it said on my slide, right? Now, pH 7 means there's a very, very small concentration of hydrogen ions. The concentration would be 1 times 10 to the negative 7. That's scientific notation. All it means is that there is 0. Okay, that is our concentration of hydrogen ions. It's also the concentration of hydroxide ions. Now, acidic solutions, remember a solution means there's like a solute and a solvent. Okay, the solvent, water is our universal solvent, is what the solute is dissolved in. So an acidic solution has a pH less than 7. And I'm going to show you the pH scale in a minute. But that means that 6, 5, 4, 3, all of those are more acidic. Okay, so acidic solutions have a higher concentration of hydrogen ions. Now, your quiz questions will not go into this much detail, but this is the background that you need to understand pH. So acidic solutions have a higher concentration of hydrogen ions. So if I have, let's say, pH 3, okay, this is acidic. So pH 3 equals a 0.001 concentration of hydrogen ions. Well, what I want you to notice here is 0.001 is a greater number than the previous number, 0.0000001, right? That's a smaller number. So what I want you to notice is that as solutions become more acidic, they have more hydrogen ions. Okay, so let's take a look at how this happens, and then I'll go into basic solutions. Now, you may or may not have heard of the acid hydrochloric acid. Now, this is present in our stomach. It's what makes it so acidic. So hydrochloric acid breaks up into hydrogen ions and chloride ions. Okay, so hydrochloric acid is donating hydrogen ions to the solution. That's what acids do. So I'm going to write down that definition for you. So acids donate hydrogen ions to the solution. That's how they make it more acidic. So you may realize at this point that a basic solution is going to have fewer hydrogen ions than neutral. So as you go up the pH scale, 8, 9, 10, the solution becomes more basic. It has fewer hydrogen ions. So basic, we also call these alkaline. Solutions have fewer hydrogen ions than pH 7. Okay, so this means that you are going up the pH scale. So for instance, a pH 9, okay, that's basic, has 0. Okay, that is the hydrogen ion concentration. Now remember, I'm doing scientific notation, but I just want you to notice that as the numbers get higher, the hydrogen ions are decreasing. So a very common base, and one that I use in a lot of my examples, is sodium hydroxide. So that is NaOH. Remember, a hydroxide ion is OH minus. That's why we call this molecule sodium hydroxide. So sodium hydroxide breaks up, we also call that dissociate, into sodium ion plus a hydroxide ion. Okay, this is a base, but how is this removing hydrogen ions? Because that's ultimately what has to happen to make a solution more basic. Well, the next reaction that occurs, you have a hydroxide ion, right? Sodium hydroxide is releasing all these hydroxide ions. And there are hydrogen ions already present in the solution. Now take a look at this. What does OH minus plus H plus form? So when those two ions combine, it forms water. Okay, so bases are removing hydrogen ions from the solution. So I'm going to write that down for you. Whoops. I may have just said that backwards, I'm not sure. But bases remove hydrogen ions from the solution. Okay, they break up and release hydroxide ions. The hydroxide ions bind with hydrogen ions to give you water. So the take-home message here is that acids donate hydrogen ions. Bases remove hydrogen ions. As you go up the pH scale, you have basic solutions. As you go down the pH scale, you have acidic solutions. So let's go back to the PowerPoint. So this slide on the PowerPoint gives you the same information that I just provided on the whiteboard. Okay, what is an acid? What is a base? Hydrochloric acid is the one that I will generally use in my test questions. Sodium hydroxide is the base that I will usually use in my test questions. An acid donates hydrogen ions. I don't know why I keep saying electrons. And a base removes hydrogen ions. Now, this is the pH scale. So this is a really clear way to see how the pH scale works. So we have neutral pH, that is pH 7. Hold on, let me move my circle. There we go, pH 7, which is pure water. Now, as the numbers on the scale decrease, goes all the way to 0, you have acidic solutions, a higher concentration of hydrogen ions than pure water. And as the pH scale goes up, 8 all the way to 14, you have basic solutions. Those have fewer hydrogen ions than pure water. So the final thing that you need to understand about pH is that buffers prevent the fluctuation of pH. Okay, a buffer is a weak acid and a weak base. Now, this is a really complicated chemical reaction I put here, so I'm just going to summarize it for you. You do not have to know carbonic acid, what the molecule is, or bicarbonate. You should know what CO2 and H2O are. So basically, let's use the example of blood. Your blood is slightly basic. Okay, I believe it's about 7.4 to 7.6. If the pH of your blood goes too high, above 7.6, or too low, below 7.4, you will die. So you have a buffer in your blood. Okay, so let me write the definition of a buffer for you. Okay, it prevents fluctuations in pH. That doesn't mean that it always maintains pH 7, right? It prevents fluctuations in a variety of pH levels, depending on the system you're looking at. So here's how this works. You naturally have carbon dioxide in your blood, and when that combines with water, you get what's called carbonic acid. Now, carbonic acid can release hydrogen ions if your blood is too basic, but and that leaves you bicarbonate ion. That can pick up hydrogen ions if your blood is too acidic. So let me summarize this for you. So a buffer removes hydrogen, I'm just gonna put H plus here, removes H plus when the pH is too acidic. It it adds, I also say donates. Let me write that here. Okay, so a buffer removes hydrogen ions, so it's acting like a base, if the pH is too acidic, right? If it's dropped too low. A buffer will also donate hydrogen ions if that pH becomes too basic, meaning the number gets higher. Okay, so for this part of the PowerPoint, I want you to understand what pH measures, the concentration of hydrogen ions. Okay, you also need to know that acidic solutions have a pH less than 7. Basic solutions have a pH above 7. And a buffer prevents fluctuations in pH or the pH level. Okay, so that is the last video for your biological chemistry PowerPoint.